Hello, I'm Dr. Steve Warner, and today I'm going to talk about the distributive property and factoring. The distributive property says that for all real numbers a, b, and c, a times b plus c is equal to a times b plus a times c. Let's look at a simple example illustrating this property. So we're going to show that 2 times 3 plus 4 is equal to 2 times 3 plus 2 times 4. Notice how the 2 is being distributed to the 3 and the 4. Okay, let's verify that this is true. Well, using basic order of operations, we first add 3 and 4 here to get 2 times 7. And 2 times 7 is 14. On the other side of the equation, we first multiply 2 times 3 to get 6, and then we multiply 2 times 4 to get 8, and we add them to get 14. Notice that the two results are the same, showing that for this particular example, the distributive property holds. Here's a geometric representation of the distributive property in the example we just did. Notice that here we have a 2 by 3 rectangle, and here we have a 2 by 4 rectangle, and when we put the two rectangles together, we get a 2 by 3 plus 4 rectangle, otherwise known as a 2 by 7 rectangle. Okay, let's add in a little algebra. We're going to use the distributive property to write each of these algebraic expressions in an equivalent form. So in this first example, we're going to distribute the 2. We get 2x plus 2 times 1 is just 2. In this second example, we'll distribute the x. We get x times y minus x times 3 can be written as 3x. And in this last one, we're going to distribute this minus sign. We get negative x, and then negative times negative is positive y. It's a common mistake that students make to forget to change that negative to a positive. If it helps, this last example can be written as negative 1 times x minus y. It means the same thing. So that's negative 1x plus 1y, which is exactly the same as what we just got. Okay, let's look at a multiple choice example. Which of the following is an equivalent simplified expression for 3 times 5x plus 8 minus 4 times 3x minus 2? We're going to have to use the distributive property twice here. So first we have 15x plus 3 times 8 is 24. And then we have negative 4 times 3x is negative 12x. And now be careful, negative 4 times negative 2 is positive 8. We now finish by combining like terms. 15x and negative 12x is 3x, and 24 and positive 8 is 32. That is choice C. Okay, let's try another example. The equation shown below is true for what value of A? Okay, in this one, I'm going to start just like in the last problem by distributing on the left. So we have 5a minus 15 minus 3a plus 6 is equal to 7a. Combine like terms on the left. 5a and negative 3a is 2a. Negative 15 and positive 6 is negative 9 equals 7a. Let's subtract 2a from each side of this equation to get negative 9 equals 5a. And finally, divide each side by 5 to get that a is negative 9/5, and that is choice B. Here's another example. A child has set up A rows of dominoes with B plus C dominoes in each row. Which of the following is an expression for the total number of dominoes that the child has set up? Well, we multiply the number of rows of dominoes, A, with B plus C dominoes in each row. And then we look, well, this isn't an answer choice, so we probably have to use the distributive property. We get A times B plus A times C, which is choice D. Let's look at another example. What polynomial must be added to x squared plus 3x minus 5 so that the sum is 5x squared minus 8? Okay, so in this problem, we want to take the sum, 5x squared minus 8, and subtract x squared plus 3x minus 5. Okay, so we need to distribute that minus sign. So we have 5x squared minus 8 minus x squared minus 3x plus 5. And now let's combine like terms. 5x squared and negative x squared is 4x squared. And we have negative 3x. And finally, we combine the negative 8 and the positive 5 to get negative 3. That's choice B. Factoring. When we use the distributive property in the opposite direction, we usually call it factoring. So in this case, we're going to be going in reverse. Let's look at this simple example. We're going to factor each of these algebraic expressions. 2x plus 4y, each of these terms has a common factor of 2. So when we factor out the 2, we're left with x plus 2y. When we factor, you can think of it as dividing. 2x divided by 2 is x, and 4y divided by 2 is 2y. 3x plus 5xy, well, each of these terms have an x in common. So we can pull out an x, and we're left with 3 plus 5y. For the last one, 6 and 9 are both divisible by 3, and we also have a y in common. So we could pull out 3y, and we're left with 2x plus 3z. Let's look at a multiple choice example. Which of the following expressions is equivalent to 5a plus 10b plus 15c? Well, each of these terms is divisible by 5. So we have 5 times a. When we divide 10b by 5, we get 2b. And when we divide 15c by 5, we get 3c. And let's see, that's choice A. Okay. The difference of two squares, a squared minus b squared, always factors as a minus b times a plus b. Let's look at a few examples here. X squared minus 9 factors as x minus 3 times x plus 3. 4x squared minus 25y squared factors as 2x minus 5y times 2x plus 5y. And 36 minus 49 x squared y squared factors as 6 minus 7xy times 6 plus 7xy. Let's try a multiple choice example. For which non-negative value of a is the expression 1 over 16 minus a squared undefined? Well, that expression will be undefined when the denominator is 0. 16 minus a squared is the difference of two squares. It factors as 4 minus a, 4 plus a. So we get two equations. 4 minus a is 0, 4 plus a is 0. This one becomes 4 equals a, and this one a equals negative 4. They asked for a non-negative value of a, so the answer is 4, choice B. Trinomial factoring. A trinomial is a polynomial with three terms. The trinomial x squared minus a plus b times x plus ab factors as x minus a times x minus b. Notice that we're only going to be factoring trinomials of a very special form, where the constant term is a times b, and the coefficient of x is negative of a plus b. So let's look at some examples. We're going to factor each of these algebraic expressions completely. X squared minus 5x plus 6. So we always get x here and x here, and the two numbers must multiply to 6, so there's going to be a 2 and a 3, and they have to add to negative 5, so that's going to be negative and a negative. You could always check this at the end by multiplying these two polynomials. You can use FOIL or the method that I prefer, which I've shown in another video. Let's try the next one. X squared minus 2x minus 35. Well, we always have an x and an x here. Now 35 is equal to 7 times 5. One of these has to be a plus and one has to be a minus, because we need to multiply to negative 35, and the bigger number is going to have the minus sign. Now the last one, x squared plus 14x plus 33. We have an x and an x, and 3 times 11 is 33, and 3 plus 11 is 14. Let's look at a multiple choice question. The expression x squared minus x minus 12 can be written as the product of two binomial factors with integer coefficients. One of the binomials is x plus 3. Which of the following is the other binomial? Okay, so we have x squared minus x minus 12 is equal to... Now this is even easier than the last problems I did, because we already have one factor. We know that the other one starts with an x, and the two numbers need to multiply to negative 12. So the other factor is x minus 4, which is choice C. One more example. For all x greater than 0, x minus 2 times x squared minus 3x minus 18 over x plus 3 times x squared minus 8x plus 12 is equivalent to what? Okay, so we're going to factor the two trinomials, one in the numerator and one in the denominator. So x squared minus 3x minus 18 factors as x minus 6, x plus 3. And x squared minus 8x plus 12 factors as x minus 6, x minus 2. Now notice we have some cancellation. The x minus 2's cancel, the x plus 3's cancel, and the x minus 6's cancel. So we're left with 1, choice A.